A widespread and extensive growth of Internet technology has brought it convenient to distribute digital data in many kinds of formats, such as digital videos, digital images, and digital audio. Assume that you have an audio file. If an anonymous person tries to modify or adapt or destroy the file, so how can you know and protect it? Based on the previous study of many research, they found that the watermarking technique is one of the solutions to manage and handle illegal cyber action such as duplication, adaptation, and distortion of the multimedia products. So we implement the watermarking technique into this project with the algorithm to embed watermark in the file by using MATLAB program to be our tools. With our new algorithm, we implement singular spectrum analysis or SSA and psychoacoustic model for selecting the interval to embed. In our project, need to meet these requirements. First is robustness. The system should be robust against many kinds of attacks that try to remove the hidden information or the watermark inside the file. Inaudibility. By listening, a human being should not distinguish the difference between the original and the watermark file. Let's see our process. We have two main processes with each embedding process and extraction process. The embedding process is to embed the watermark to the audio file, where the extraction process is to extract the watermark from the watermarked file.
So, let's start with the embedding process. First, segmentation. A signal is segmented into frames in order to embed the watermark in each frame. At the same time, a signal is measured the interval that suits with inaudible part based on human perception, which is used to identify the embedding part in the frequency band selection based on psychoacoustic model. After we segment as a frame, in the metric formation, each frame is performed as metric test. Then we expand metric by performing singular value decomposition to prepare to embed the watermark. From the above step, the output is the interval which is represented as the frequency. But in the embedding process, we modify the singular value which is represented as an index. So we need to map the frequency domain into index domain in order to identify the index to embed. This process is singular value modification, which we need watermark and the interval chosen by psychoacoustic model as the input. Then we modify singular value of the orthogonal matrix from our embedding rules. Then we do the hierarchization in order to combine matrices into one matrix after embed the watermark. Next, we perform segment reconstruction in order to transform matrix to be a signal.
For the extraction process, the first three sub-processes are similar to the embedding process, but the first step is decoding the singular value, which we will get the extracted watermark from the watermarked signal. For the feature list, we almost finished all the tasks we planned in both embedding and extraction process. The remaining task is to test the result of our algorithm by trying to extract the watermark signal in different signal processing methods. Let's see the sample result before and after watermark the file. These are some of our sample code. This is the singular value in embedding part of original and watermark file. This is the output from frequency to index function, which the frequency band chosen by psychoacoustic model.